Solving cubic inequalities. So at the moment we've sketched some graphs of different kinds of cubics and we've also gone and factorized cubics, we've divided cubics, and now we need to solve different kinds of cubic equations. Now when we're solving inequalities, much like when we solve quadratic inequalities, don't try to solve it linearly, don't try to move things on either side, no, draw the graph. I assure you, that is the easiest and best way. I know you don't want to draw the graph. I know you're sitting there going, ugh, graph. But you really should draw the graph because it makes this bit much easier. So, the first question says here that we want to solve the following cubic inequalities. And this first one here is x minus 1, x plus 2, x minus 3 is less than or equal to 0. So what I'm going to do is I'm going to draw a very rough graph. Since the question doesn't actually ask me to draw the graph, I don't have to be as precise. But I know I've got an x-intercept at x equals -2. I've got an x-intercept at x equals 1. And I've got an x-intercept at x equals 3. So it's going to look something like this. Well, that's 3, 0. That's 1, 0. And that's -2, 0. So the points on the graph that is less than or equal to 0, so if we highlight that friend there, so less than or equal to, well, that's from here, and it's here. Because what does that mean? Less than or equal, if I'm asking where is that graph, or where is that equation less than 0, what I'm saying is what part of the graph is underneath the x-axis. So if I was saying greater than, it's which parts are above the x-axis. And obviously if it's equal, it's where it's on the x-axis. So the yellow highlighting bits is the bits where the graph is underneath the x-axis. So the answer to this, so my answer is simply just x is an element of -infinity to -2 inclusive, and 1, 2, 3. I'm using interval notation because I can. I think that would just be best. You could write it in the set notation. Neater. Anyway. So this one is asking for greater than. So let's get a different color. Oh, where's my green? Green was somewhere. Don't tell me I've got rid of it. Oh no, there it is. So we want greater than or equal to 0. So we'll draw this friend out. Whoop, yep. I have to make the noises when we're drawing graphs, as you'll be aware. So we've got an x-intercept at -2, at -1, and +4. So it's going to look something like this. It's not the greatest graph, I will admit. I'm sorry. Please don't send me to the graph committee. We want it greater than 0. So the parts that's greater than 0, that's this, greater than or equal to 0. It's going to be this bit and this bit here. So my answer is that x is an element of, we'll start with an interval, -2 and -1, union 4 to infinity. Splendid, so that's very straightforward. The next one here says, solve the following cubic inequalities, begin by getting all the terms on one side. Yes, I would highly recommend it. What I'm going to be doing is I'm going to move the 6 onto the left-hand side, and then what I'm going to do is I'm going to factorize that, and then what that will do is I'll be looking for any values that are greater than or equal to 0, and I'll show you what I mean by that in just a moment. So what I'm going to do is I'm just going to -6 on both sides, and I get x cubed minus, I said x cubed, come on dear, x cubed minus 6x squared plus x minus 6 is greater than or equal to 0. So as per usual, I'm going to need to find a factor that'll be able to fit nicely in there. be crazy. But if I put 6 in there, that could also work. Let's try 6, p of 6. The reason is that even though x6 cubed is quite horrible, 6 times 6 squared would also be 6 cubed. So I'd have 6 cubed take away 6 cubed, which is already 0, plus another 6 take away another 6. That will definitely equal 0. So therefore, x minus 6 is a factor. Go us. So what I can now do is I can now do my lovely bit of a long division. And we'll set this up here. And 6 cubed divided by x, 6 cubed. X cubed divided by x will be x squared. X squared times by x is x cubed. X squared times by negative 6 is negative 6x squared. Oh, we've got some bits of cancelling going on here. Because these two, or both of these will end up being equaling to 0. So we'll need to bring these two friends down. So then, x divided by x is 1. So 1 times x is x. 1 times negative 6 is negative 6. We've got a 0. Ooh, interesting. We've got a weird looking factor. So our factorized form is x minus 6, x squared plus 1. Now this is very interesting looking graph because it's weird. We've got an x-intercept here. Now imagine trying to put x squared plus 1 equals 0. Is this going to be an x-intercept? Well, if I was just to make x squared plus 1 equals 0, I'd get x squared equals negative 1. Can't have x squared as negative 1. So therefore, nope, it's not an x-intercept. So it's actually a weird looking cubic equation, cubic graph. What I'm going to do is I'm going to show you what this graph looks like. It's a really delightfully weird graph. So let's move you over here. Let us put up the graphing table and get rid of this nonsense, whatever I had going on here. Yes. X minus 6, x squared plus 1. And we'll set this to default. And we'll draw this friend. Now you can see here. Now, if I zoom out a little, so I'll make that y minimum, let's say, negative 20. And let's keep it as that. Let's get my y scale is at negative 2. Oh, 2, sorry. There we go. Okay, we'll need to make that a little bit deeper. Say negative 100. Let's make the scale 10. And there's, look at that beautiful looking graph. Weird as all heck, but a very beautiful looking graph. So it actually turns, you can see here, it actually turns at that y-intercept, which is just beautiful. There we go. So it actually turns at the, or nearly near enough turns at the y-intercept. So there we go. So yeah, it only has one intercept and it's going to look a little bit weird. So the graph itself looks something like this. And so that's going to be at 6, 0. Now, remind me, what was the question? It was actually asking you, well, now greater than 0. So, the long and short of it is, the question was, we needed to find what values of x would be greater than or equal to 6, and we've turned that into greater than or equal to 0. So, the parts of the graph that are now greater than or equal to 0 is this bit here. So, I'll get rid of the word answer because that's misleading. That's not the answer. The answer is x is greater than or equal to 6. Easy as that. On the one set of axes, sketch the graphs of f of x equals x cubed and g of x is equal to 2x squared. Solve the equation when they're equal. Solve the equation when f of x is less than or equal to g of x. Okay. Get my perfectly ruled axis here. Now, when drawing this, I would highly recommend just getting a couple of points ready. So the points that you need to know is, because it's really hard, the quadratic and the cubic sort of duck and weave amongst each other. So we want to make sure that we do the same. We have to know where it ducks and weaves. So the first thing I would do is find out where they're equal to each other. So let's go and find that so we know the points of intersection. So we'll do x cubed equals 2x squared. Remember, we don't want to cancel out x's here. We want to go in minus 2x squared on both sides and get x cubed minus 2x squared is equal to 0. Take a common factor out of x squared, minus 2 equals 0, and get x equals 0 or x equals 2. So that's where they intersect. So I know at the points at the origin, at 0, 0, and when x equals 2, they will both intersect. So what I'm going to do is I'm going to also, just for a point of reference, so point of ref. The reason I put a point of reference in is that I will draw the cubic, say like that, but sometimes it's hard to tell if the parabola is going to do this, which is that 2x squared, or if it's going to do this. And I'd like to know where it's going to end up. So my point of reference, I know that they intersect between 0 and 2. I just want to know where the two graphs are when x equals 1, and that way I know where in between should be. So for f of 1 is equal to 1 cubed, which is 1. G of 1 is equal to 2 times 1 squared, which is equal to 2. So therefore, the quadratic will be at a higher point. So let's make g of x this red one. And let's make this cubic looking like this. So I'm going to call that point of intersection, that's going to be at x equals 2, and that will be 8. How did I get that? I just substituted 2 into the x cubed here, which is the same as substituting the 2 into 2x squared. 0, 0. That would be 1, 2, 1. There we go. So the question now is saying solve the equation when f of x is equal to g of x. Well, we've done that. So for answer for B is going to be when x is equal to 0, x is equal to 2. That's the points. Or we would say we can put the coordinates in there, 0, 0, to 8. For C, the points where the graph of f of x, the cubic, is less than or equal to g of x. So less than or equal to g of x, that's going to be this entire bit here. So it's going to be x is less than or equal to 2. Or you can write it as negative infinity to 2. Now, had that have been a different question, so alternatively, if that had said f of x is less than g of x, well, we'd actually write that as x, it would have to be separate intervals. It would have to be x as an element of negative infinity to 0, not inclusive, and then greater than 0 to 2, not inclusive. So that's if that question had said less than, because we couldn't have it at 0 because it's not, that would be where it's equal to the other graph. So that's what we'd have to write there. And so there's cubic inequalities.